You please patiently wait up to minimum 90%. More than 90 is too good, but you don't need to wait up to that. 90 is fine, it's optimal. And you can also observe how much flash memory, how much RAM it is taking, and also you can see the confusion matrix. You can see the confusion matrix, okay? And few more things also you can observe. You see that search space. So now it's PCA, how you can see that XBG is there, RF is there, Lightforest is there, MLP is there, SCFR is there, SVM is there. For all these things, how the search space is happening, and here few more options are there. Still I could see the real-time performance evolution model. You can see that, and crash validation results, and your library tested by model. So you can see all those values. All these graphs will be useful for your papers.
We cannot upload the direct data to AGI without capturing from.
You can.
We can upload.
You can direct that CSV file if it is there.
Yeah.
You can directly upload.
Without having.
See here, so it's all happening, but still my expected accuracy is not done. Maybe it take even it tested with 1500 libraries, but still it couldn't able to get the balanced accuracy of 90%. So it may be due to the data what we have collected. Okay, the data may not be proper. Okay, but still we can wait, or if it is not coming in another 1 minute, I will stop this and we'll go to the next one. So you can capture all these images for your paper. So now I feel that at least you people ask your students to use this board. If any machinery related projects. Obviously if they put all these graphs on the paper, grading acceptance is very easy. So shall I stop this now? Okay. So I felt okay, 82.5 is somewhat okay. Okay. So how we can do this? Click pass. Click pass. It will pass. Okay. So next, training part is done. Training part is done with almost 2000 libraries it tested. Okay. Where this training is happened is not on board. It's on cloud. It's happened. Okay. So click validation. Okay, click validation, and you see that in this validation it will show all the different ML model, okay, with its your balanced accuracy, with its RAM and flash memory, how much is required. You can see the maximum accuracy was 82.61. You can see the maximum accuracy was 82.61. For this balanced accuracy, 7.2 KB of RAM and 53 KB of flash memory is required. Okay, if this much space is there in your model, your board, you can select that one. No sir, that much is not there. I have only 33 or 35 KB flash memory, means you have to go with this one. Okay, but our model is having 128 KB RAM and 1024 KB of flash memory. So I am haram said to go with the 30th library. So you see that model, machine learning model, what it is? MLP. So MLP is giving a good result. It's a multi-layer perceptron. Multi-layer perceptron is giving good accuracy now. So now I'm going to test it. I'm going to validate it. Okay, how I'm going to validate is, you see that there is an option called serial emulator. Can you see this? Serial emulator. Click the serial emulator. Okay, it will take you to the validation phase. So as I told, if I move like this, it should show XY. If I move like this, it should show YZ. Okay, and if I move like this, it should show ZX. Okay, so how to do it? Again, connect the port, and I don't want to restrict my samples. Click start. Click start, and my device is collecting. And you can see that I'm just rotating in XY. You see that it's showing XY. Class detected is XY. Okay, and now you see that YZ. Okay, now you can see that, yeah, see that ZX. So now XY, YZ, ZX. ZX only, the data are not proper. You can see that ZX now. So all these things are now the classification is perfect. So our logger, training, testing, everything is done pakka. Okay, got it? Now it's working fine. So now once it is done, you can stop it. Now what we have done is on dashboard we tested. Okay, suppose if you want to deploy, because for this obviously you need internet. If you want to do this testing, you need an internet connection. So no sir, I want to do it on my board. I don't want to connect with the internet. Okay, in such cases what you have to do is you close this, stop it and close this. Okay, and go to the next step, deployment. Okay, go to the deployment and select this mfloat-API and click this deploy library and get library. Okay, it will ask you to give the feedback. Yes, so save library. It will give you one zip file. Okay, it will give you one zip file, and that zip file you open it. You can see that inside there are three files. These three files are very important. One is nanohei.h, the other one is libnei.a, and next one is knowledge.h. So these three files are very important. With this three file only we are going to deploy it. Okay, I'll share the slide. I have shared our files already. Coding I have shared already. So once you deploy it, nothing here, no need of a nano-HI dashboard and all. That you can go. Okay, so I'll just quickly show that also. Go to QIDE because I already that deployment is done already. I just open and I'll show you there is a value. So deploy. See, I just open this directly. So I just opened the main.c file directly. So here only deployment is done. You can see that there are some files are available. mp.h, knowledge.h, nano-h. Okay, and here what I have collected yesterday data is xy and yz only I collected just for testing it. So with that same code only I will go. Okay, so just click the debug. So its debug is done. There is no error. So now see, there is no internet connection required for the once it's deployed. No internet connection is required. So code is loaded. And I just go to the serial code. Okay, and now I just click the resume button. And you can see that knowledge initialization is done. It is showing the detection as YZ. Detected access is YZ. Maybe it's not showing because the data collected for this is something different. Yesterday you were connected. So it's not showing the problem. Only YZ is showing. If you go with the date file what we have saved now, so it will give you the correct classification. Okay, so now there is no internet connection is required. In console you can see that, or else you can connect one LCD display. Okay, in the LCD display you can see that what is detected accesses. Okay, this is how the deployment happened. Okay, so whatever we did so far, it's only a classification problem. Okay, so immediately quickly I will show you one anomaly detection. Okay, so for anomaly detection, what I did is I take one current sensor. Okay, I collect quickly collect the data for with load and without load. Okay, with load, without load, how I am taking is I am not going to disturb my current input. It will show some data, and I am going to disturb that one, so it will give some data. Okay, with that, if I disturb it, it is anomaly. If I don't disturb it, it's fine. That way I am going to do the anomaly detection. So for that purpose, so inside your box you can see that one sensor called ACS723. One sensor called ACS723. Okay, it is a simple current sensor. Okay, you take that one, just remove this, and for this ACS723, you need to give 5 volts, not 3.3 volts. So change that power terminal to 5 volts. Okay. See what I did? VCC to 5 volt and ground to ground I connected, and one thing you can see that V out. Okay, that V out where you have to connect is A5 I will connect. A5 I will connect. A5. Okay. And now, sir, another chance. Okay. So maybe I already sent you the code. You can see that ACS log code. ACS log code is there. I already sent you. Just I opened that IOC file. I will show you what you have to enable it. That I will tell you. You can see that PC not. Pin number PC not. It is enabled for ADC channel. Okay, and once that is done, go to the analog channel. Okay, and you can see that ADC 1. Okay, and you can see that in one usually by default it will be like this. I just enabled it in one single ended. Okay, once this is done, then that's it. Only this setting is required on hardware. Okay, I'm not going to change because it's already done. I don't want to change it. Okay, so directly what I do, I directly go to the main.c. So I just want to show you how this ACS sensor is working. That's nothing else. Maybe you can test it. I have given the code already. You can test it. So I just built it. No errors. I just debug it. I think there is no error. Yeah, fine. I'll open the console. Test file. Yeah, now you can see that nothing is showing. Okay, I just click the resume button. You can see that some value is showing. Okay, it's now zero current. Actually speaking, because no currents are flowing through the sensor. You can see that there are two ends. Okay, the current will connect with one point and go out in the other point. Okay, the current will flow this way. So now actually zero current is connected. It's showing zero value. Now I just simply disturb it. You can see there. Can you see? I'm just disturbing the sensor. You can see that value is getting changed. If I leave it simply for some time, no, the values are different. Okay. With this, I'm going to detect the anomaly. Okay. So now my sensor is working fine. Okay. I just terminate this. Again, close this. I don't want it again. I just open the Nano HAI. So now the problem is different. You should not go for classification. You should go for anomaly detection. So again, click the new project. Okay, detect anomalies. Okay, create. Again, you save the file with some name. Current detect. Okay, save it. Select the target. Okay, and allow the complete memory. Okay, and now you have to select the sensor. Our sensor is the current sensor, and our sensor is one axis sensor, one axis current sensor. Okay, click save. So now you have to select, you have to find two signal. One is regular signal, it means without disturbance I select one signal. Then with disturbance I select one signal. Okay, click add signal, log signal, start. Okay, let it collect the data. Okay, now it's without disturbance. I didn't disturb it, it's collecting the data now. So let it go for at least some 50 signals. So you can easily, what you can do is you can connect this current sensor. Okay, maybe for example, up to your rated condition, rated load. Okay, it will take some current. So you can take that data as your regular data. Okay, and if it is more than the load, some current values will be there that you can record it. So what you can do now, if you allow the machine to operate with rated load, it will show that it's normal, it's regular. Okay, if the current is exceeded, it will show that it's anomaly is happening. That way you can do a lot of projects. Okay, so I just stop 40 signals I collected, stop it. Next, don't do any change, import. Okay, so now the regular signal is done. I'll go with anomaly. Okay, I'll go with anomaly, add signal, log signal. Okay, start. Now I'm going to completely disturb my sensor. So you see that I'm just disturbing the sensor. It will take some random data. You can see that it's going up to 0.12. You can see now the key values keep varying. So it's just a random thing I'm doing it. Okay, it's not the right one what I'm doing it, but just to give a demonstration, I'm just doing it. Okay. So sometimes some peaks are coming, sometimes no peaks. Okay. Okay. But if your data is not proper, it will not happen properly. Okay, so 30 signals I collected. I just stop. Okay, done. I just click next. Import. So now both the data are collected. A regular signal is collected. Abnormal signal is also collected. Okay. So as usual, go to the benchmark and train both the signal. Okay. Start. So now for anomaly detection, algorithms are different. So not the same because classification algorithms are different. Anomaly detection is different. Okay. So here I think ZSM, zero score method, micro machine learning, then incremental PCA, all these algorithms will come into the picture. So now you can see that the training is happening. So now the balanced accuracy is only 56%. So we got to 90%. See that when you look at your confusion matrix, you can observe. Yeah, now you see that balanced accuracy 94%. So now your model is perfectly trained. Okay, pause it. Okay, pause it. Go to the validation. Okay, and you see that which one gave good result. You see that IPSA, incremental PCA, is given a very paka result. It's about 94% accuracy. But you look at the RAM size. Look at the RAM size. It took 33 KB. And look at the flash memory, 35 KB. That's fine. But RAM, it took 33 KB. Okay, so but our model is having it, that's no problem. So once this is done, now we are going for the validation. So for validation, click the serial emulator. Once you click the serial emulator, it will go to this page. Just wait for some seconds to come out. Yeah. So now, what we did actually, we collected the data and we trained the data. Now for the anomaly detection, some learning is also required. Okay, that learning I am doing it now. So minimum we have to allow it for 20 iterations. Then maximum we can allow it to 80 iterations. But I am allowing it for 20 iterations. Okay, so start learning. Now your model is learning. It's not connected. It's learning now. The pattern it is learning now. Okay. You do disturbance or just keep it idle also, no problem. But you just allow it up to 20 iterations. I'm just giving some disturbance there, then and there, so that you can see at the top serial output, you can see the disturbance. And now it's learning. It's about some 15 iterations are over. And wait up to 20 iterations minimum. Then you can stop it. Okay, just leave it simply. So now 20 iterations are done, but it will go if you don't restrict, but we can stop it, stop now. Now your model is learned. Okay, so yeah, I can see that anomaly is detected. I just connected continuously. See that it's abnormal signal.
So in the program you set threshold values in the program.
We have not set any threshold.
Then how to classify it?
That's what I told you. We collected the data for normal and abnormal. Okay, with that, based on that data, it is detecting now. Okay, so this is how your anomaly detection works. Okay, so all these, but here you should know the hardware knowledge. If you have the hardware knowledge, you can do it. Okay, so